Hi, Angie. This is your lesson, electricity, okay? Wanna share my screen? Okay. Today is a really exciting lesson, okay. Okay, so electricity is something that you use in your life, in daily life, in many ways, like what you use to turn on the TV or the light bulb or charge your computer, okay? You are really comfortable using it, but still you have to respect its power because when you use it in a bad way, it can be dangerous, okay? Electricity is a gift from God, but you have to use it carefully and safely. And scientists have learned that electricity has several forms and many uses. And they know a lot about electricity, but there are still things that we don't know. For example, we know how electricity acts, but we don't always know why it acts that way. Okay, so for your vocabulary today, it's a long one, so be patient with me. We have the word acid, ácido, which is a liquid with a sour taste, like that of vinegar, and I give you an example like lemon juice, it's an acid. Then we have the word atom, átomo, the smallest part of any object. Okay, then attract, atraer, to draw towards yourself, acercar a uno mismo. The word connect, conectar, to join one thing with another, like this, or like with puzzle pieces, juntar una cosa con otra. Electrical, eléctrico, having to do with electricity, que tiene que ver con la electricidad. Okay. Then electron, electron, it's a particle in an atom, like this one here, that is found in the area surrounding the nucleus. Nucleus is this part, and is negative in charge. Es una partícula, o sea, algo muy, muy pequeñito en un átomo que se encuentra en el área que rodea al núcleo. Este es el núcleo, este es el electrón y es negativo en su carga. You're going to understand more in a moment, don't worry. Okay, then the word negative, okay? A charge made from having extra electrons. Una carga hecha por tener electrones extra, carga negativa, okay? Neutral, having either a positive nor a negative electrical charge. Tener una carga que ni es positiva ni es negativa, es neutra. Okay, then particle, partícula, it's a very tiny bit, something really, really small. Okay? Okay, then positive, positivo, a charge made from a lack of electrons. Una carga hecha por falta de electrones, okay? So something positive, and you're gonna understand more in a moment. Don't worry about the vocabulary. You'll see more in a moment, okay? I'm just reading to you and I'm sending the document so you can reference it back when you need to and copy it in your notebook, okay? Then we have the word proton. It's a particle, like this one, in an atom that it's found in the nucleus and is positive in charge. Una partícula en el átomo que se encuentra en el núcleo y tiene una carga positiva. Okay, now that we're done with the vocabulary, we're gonna talk about something else, okay? This part of our lesson is called From Electrons to Electric Current, okay? So atoms, electrons, and electricity are all related, okay? Something key to understand them was to understand lightning and also the atom, okay? This is a picture of lightning like in an electric storm, okay? Sometimes when there are many clouds and they are dark and heavy, there will be thunder and lightning, okay? And lightning, it's a huge static spark, okay? And now I'm gonna tell you about Benjamin Franklin, okay? This man here was Benjamin Franklin, okay? Lightning, it's a wonder of nature. It has frightened and puzzled people since the beginning. Even Job mentioned it in the Bible, describing it with respect, knowing that it came from God, but not understanding it that much, okay? Many times in the Bible, writers use the example of lightning to describe the power of God because lightnings are really powerful, okay? This man here, Benjamin Franklin, did a famous experiment with lightning because he wanted to understand it, okay? And remember that lightning has to do with electricity, and I'm gonna explain more in a moment, okay? So what he had is a key and a kite, okay? And he attached the key to a kite and make it fly, okay? During a storm, that's the thing. The kite soon became electrically charged, and I'm gonna explain a little bit more in a moment about that, okay? So the electrons move down the string to the key, and Ben held his finger near the key, and sparks jumped from the key to his finger. And that was really dangerous because he could have been struck by lightning, okay? But this experiment led him to figure out a way to protect people, buildings, and ships from lightning. He did an experiment called a lightning rod. It's something like this. You have like a little rod on the roof of a house, and it catches lightning, so it doesn't go inside the house, okay? And then it sends it to the ground, okay? And here it's the lightning rod up close, okay? Like this. Okay. And now I'm gonna go and explain more about atoms and electricity so it all makes sense, okay? So the power of electricity, and electricity is what happens, for example, in your house when you're using appliances, but also within lighting, okay? The power of electricity starts with something really, really small called the atom, okay? All objects are made of atoms. You are made out of atoms. The chair, the things that you are using right now, your laptop, your pencil, all of it, it's made out of atoms, okay? And atoms are made of tiny particles, and these particles have a name. They are called atoms, neutrons, and electrons. Let me show you a picture, okay? Okay, so this is like a drawing of an atom. And remember that an atom is really small and you can only see it with a microscope, okay? So, and atoms make up the things, okay? So here you have the nucleus of the atom. And in the nucleus, you have two different types of particles. The proton, which has a positive charge, and then you have the neutron, which has a neutral charge. It's not positive and not negative, okay? And then flying around the nucleus, you have the electron. The electron is a particle that has a negative charge, and it's really, really small, smaller than the nucleus, okay? So you have a lot of electrons flying around. Okay, I'm gonna take this back. Okay. You are made up of billions and billions of atoms, and also the objects around you. As I will explain you, it has a nucleus with protons and neutrons, and then you have electrons flying around, okay? And to give you an example, it's just like saying that you have a football field and you have a like a ball in the middle, okay? So this ball in the middle would be the nucleus, and all the field and all the bleachers, the stairs, would be the electrons. Like that, can you see like the distance? It's like surrounding all of it, okay? And the electrons are always moving, but the nucleus that has the protons and the neutrons are not moving. Only the electrons move around, okay? And it's the moving electrons around the nucleus that create electricity. So electrons are really important for electricity. Usually, we don't see electricity, but one case where you do see it, it's in the form of lightning, okay? And lightning occurs when lots of electrons move to one place to the other very quickly, causing a spark. Electrons gather in one place, for example, a cloud, okay? And the clouds become very negative in charge because remember that electrons have a negative charge, okay? And then the electrons move quickly from the cloud to an area that is very positive in charge, like the ground or maybe another cloud, okay? And that causes that movement, that fast movement, causes a big spark that we call lightning. Lightning can happen between the ground to the cloud, from a cloud to the ground, or from cloud to cloud. It is always about negative charge, about electrons moving towards a positive charge, okay? And here I'm gonna talk about a little experiment, okay? Your hair, that's the experiment that your lesson is talking about. It's that you grab a balloon and you wrap it in your hair, and then you can actually stick it on the wall, okay? And it stays there, and I'm gonna show you in a moment, okay? But when you do that, your hair starts to stick out, okay? Start to stick out, and the balloon sticks on the wall, okay? And why does this happen, okay? It's because usually the hair and your balloon are neutral in charge. So they have equal numbers of positive and negative charges, okay? But when you wrap the balloon on your hair, electrons move from your hair to the balloon. And this makes the balloon become charged and it sticks to the wall because it's charged, okay? But now your hair lost electrons. So each strand of hair, like strands like this, cada pelito, okay, has become positively charged. And when charged are the same, they want to go away from each other. They repel each other. So your hair start to move out, move apart, like what happens to this girl. Positive charge are attracted to negative charge, and negative charges are attracted to positive charges. So we can say opposite charges attract. Negative and positive want to be together. But if objects have the same charge or a like charge, like negative and negative, they don't want to be together. They want to be apart. Or if you have positive and positive, they want to be apart. Okay, they repel each other. Okay, Ange, that would be it for the lesson today, besides watching the experiment. That's it.